Finally, it is here. Primelister has officially gone multicore. To demonstrate the massive performance gains, we will dive straight into benchmarks conducted across 3 different machines: a legacy laptop, a modern 2023 mobile setup, and a high-end workstation. If you're interested in how exactly Primelister generates prime numbers, check out the dedicated videos on our channel. I am very sure that you have this strategy, only seen it with us so far. We start with our baseline using version 2.6 on an Intel i7-9750H with 12 threads. For a calculation limit of 1 billion, the system achieved a rate of approximately 54.8 million primes per second. Moving to more modern hardware, we tested the Intel Core Ultra 7155U. With its 14 threads, version 2.6 shows a significant performance jump, reaching a peak of roughly 86.5 million primes per second at the 1 billion mark. Our Armageddon setup features the Intel Xeon W7-3455 with 48 threads. Here, version 2.6 scales even further, hitting an impressive 139.4 million primes per second for calculations up to 2 billion. This summary of version 2.6 shows a clear scaling path. As we move from 12 to 48 threads, the performance increases from 54 million to nearly 140 million primes per second. To push these boundaries, we developed version 2.9. This code dynamically adapts to the host hardware through 4 key features: automated performance calibration at startup, adaptive load balancing, cache-centric memory management, and the use of native hardware intrinsics for accelerated bit-level processing. Returning to the i7 laptop with version 2.9, the impact is immediate. Performance at the 1 billion mark increased from our previous 54 million to 61 million, with a peak of nearly 76 million primes per second at lower limits. The Ultra 7 laptop saw an even larger boost. Version 2.9 pushed the performance to a peak of 121.9 million primes per second, showcasing the efficiency of our new cache management. On the high-end Xeon workstation, version 2.9 reached our absolute peak of 145.9 million primes per second. Overall, version 2.9 provides a higher peak performance floor across all hardware tiers. Looking at the head-to-head comparison, the advantage of hardware-aware optimization is undeniable. Version 2.9 outperforms 2.6 in the sweet spots, particularly on modern architectures where thread management is critical. All source codes, including the original ImageJ macro for educational purposes and the compiled binaries for Visual Studio 2026, are available on our GitHub repositories. Thank you for your attention, and have a nice day.